on the web, and he's pioneered the development of personal-sized stellarators.
Personal stellator.
With the idea that eventually these methods could be used for rapid prototyping of more regular-sized stellarators, so that you could try lots of different ideas on configurations and make a big impact on fusion energy research. I'll turn it over to him. And he has pieces of his stellarator that he'll show if you wait till.
Spoiler alert.
Good afternoon. Thanks for coming. My name is Vicente Geral, and I'm going to present the UST1 accelerator and the status of the 3D printed UST2 accelerator. Okay. First, small background, data, some ideas, basic ideas of UST1 and UST2, because some people perhaps don't know about them. Later, I will start with UST1, conceptual design, the engineering design, the validation of the design performance.
Use this instead.
Have to turn it on.
Yeah, it's on.
No, there is. Yeah, okay. Thanks. The results and conclusions, and later, UST2, the experimental validation of some engineering concepts, the assessment of different magnetic configurations, and the engineering design and the future work. First, background, you know the background of my work. Now, at the present moment, I'm on leave of absence from the National Fusion Laboratory, CIEMAT, in Spain. I worked in CIEMAT for almost 5 years in remote handling for IRNIF, International Fusion Materials Irradiation Facility, also for ITER, and also for them, but mainly remote handling. Up to now, I developed work in accelerators by my own, in my personal laboratory, and with personal funds, but with some help from CIEMAT, people from CIEMAT, and means also from CIEMAT. Remember, this work is research and development and innovation in engineering, mainly focused on the construction methods for accelerators. And it's not focused on the plasma physics or plasma experiments or physics. In UST1, you see the facility, and here the accelerator was designed, was built, and was operated from 2005 to 2007 in my personal laboratory. The cost of the whole facility was about 3,000 euros, and the coils were built by a new special toroidal milling machine. At the end, correct magnetic surfaces were proved by electron near field line mapping, and some poor plasmas were obtained, only poor. Motivation was formation, my formation the other people if possible, and to develop new innovative methods to build accelerators. Also to try to generate demonstration effect, that is, other people can say, okay, if this person made an accelerator, we can do also this.
How did you decide on the coils that you put on?
Okay, yes,
Okay.
This is only to know in general 2 pages. About UST2. UST2 has been designed the second part of the last year, and the first part of this year, also in my laboratory, with some help from CIEMAT. Important thing in this development is the integration of the construction methods with the design. We have to do the design appropriate for the construction methods. And the method for this will be 3D printing. It's additive manufacturing, it's the same. Up to now, some pieces, prototype pieces, have been produced for this accelerator. Here we see one prototype of the pieces in this one sector, that will be one of these. And this is the concept, the design that I'm going to build. Starting with the design, construction, and results in UST1, and the conceptual design of UST1. To better understand the development, only to say is the history of the development. First, at the beginning, I thought to build a tokamak, a small tokamak, about 6 times smaller than the 80 tokamak, the Brazilian tokamak. But I estimated the power in the central solenoid, and this is a compact tokamak. Then the voltage and the power was huge, so due to safety issues, the difficulty to produce this with capacitors, and also the short pulse that I will obtain, so the diagnostic would be very difficult. I rejected this alternative. And I started thinking in an accelerator. Accelerator could be similar to a light bulb, low temperature, no problems. So seeing the different alternatives in the bibliography, I decided to build something similar to CTA accelerator, and it's a torsatron, and when the stage 7 is that is modular coils, but the surface circular, like this, circular surface, winding surface in toroidal and in toroidal direction, similar to a tokamak. First, I liked modular accelerators because they have only one set of coils, have some advantages. But I had no means to design the modular coil, so I decided to build a classical accelerator. But when I had classical accelerator design, I realized that perhaps I could do the same for a modular accelerator. At the end, with this is a Java code, I obtained the coils. I decided to build a modular coil, a modular accelerator with modular coils. Relatively compact accelerator was aimed, simple winding surface to be able to finish the development with viable funds, and to obtain basic confinement properties. For example, to avoid low order rationals, to avoid low order islands, and to try with the minimum of the module of the magnetic field on one trajectory, try to optimize a bit the confinement. At the end, the accelerator is a 2-period accelerator, 1 liter plasma volume. The mature radius is very small, like this, 125 millimeters only. The aspect ratio is 6, so the manual radius is about 20. Magnetic field is 0.1 Tesla, and 0.05 Tesla also. And the rotational transform is below the rational 1/3, 0.32 or 0.88 at the edge. The appropriate plot of the one-cut toroidal cut. Some remaining islands here, but not important, and that is the external stochastic region. This is the iota profile, the magnetic well profile, and this is the magnetic well on one surface. Here we see this modular ripple, and here these are the minimum of the modulus of B that should be on one. The same value to have beta confinement, but I couldn't achieve this. But okay, I achieved something. All this is made by the Castle code, this is the Java code I developed during several years. The specifications of the coils, they are modular coils, there are 12 modular coils. They are defined by shaping parameters of the coils, so that these 4 parameters. The winding pack is very small, 7 millimeters width, like this, and 10.5 millimeters tall depth. The conductor type is this flexible conductor, a sleeve with a single sleeve. I made inside also in the laboratory, in my house really. And the winding surface, as I said, is circular, colloidally and toroidally. The shaping parameters here, they are 4 parameters that define the formation of the coil at 4 colloidal angles. Over here is one deformation, another formation, another side, and this is the side and the shape for UST1. I obtained this after a lot of iterations, more than 10,000. So you generate one configuration from 4 parameters, and you have the configuration. And you calculate plasma volume, you calculate iota profile in 2 points, you calculate also the standard deviation of the module of or be on the trajectory. You calculate several things. You